Hello, in this lesson, I would like to talk about some common mistakes in trigonometry. I see these common mistakes in not only in trigonometry, I also see the same mistakes in pre-cal and calculus classes. Okay, so I'd like to take this opportunity to talk about, why there are mistakes and what will be the right one to do. Okay. The first of such mistake, common mistake, which I see very, very often, okay, when I saw it when I was a TA in graduate school, is that sine of 2x equals to 2 times sine x. Okay, so this is one of those very bad mistakes. Okay, this is a mistake. The correct, as we know, right, the correct one is sine of double angle equals to 2 times sine x multiplied cosine x. So that is a very, very bad mistake. It looks like the student just take out the 2 and take it outside sine x. You cannot do that. You cannot do that. Okay. And to demonstrate that these two are not the same, we can just use some examples. We can just use some examples. Okay, example to show that these two are not the same, right? Because remember mathematical fact, if true, always true, false, once false. For example, if I assume x equals to, say, pi over 4, I just give an example, okay? Pi over 4, okay? And the left-hand side of sine of 2x, right? So the left-hand side equals to, which is sine of double x, right? And that should be equals to what? What does it equal to? Well, we're going to replace x by pi over 4, right? And they actually should be in parentheses because we're going to do the 2 times x first. So that will lead us to sine of pi over 2. And sine pi over 2 equals to 1. And what is on the right-hand side? The right-hand side, we got 2 times sine x. 2 times sine x. So since x equals pi over 4, we're going to replace x by pi over 4. And then we get a 2 times sine pi over 4 equals to root 2 over 2. Right? And when we multiply these two, we got a root 2. So this statement, okay, so this statement is a false when x equals to pi over 4. False ones, false, right? False ones, thus it is false. It is false. Okay, so please don't make this mistake. This is a very, very bad mistake. And I see it most often actually in calculus classes. The second mistake I saw, okay, was this one. The second mistake. The second mistake I saw in the past is this one, okay? The student will say arctangent of -1 is equals to 3 pi over 4. And he has a reason, he or she has a reason, because tangent of 3 pi over 4 equals to -1. Is that right or not? Is that right or not? Think about it. Of course it's wrong, all right? We're talking about common mistakes. What is wrong with this statement? with or without a reason? Well, arctangent function has a domain and range. Has a domain and range. The domain is all real numbers. Okay, the input is a ratio, and the ratio can be any real number. So the domain for arctangent is any real number. It produces an angle. It produces an angle, but the angle produced is in a range, and that range is negative pi over 4. I'm sorry, negative pi over 2 to pi over 2. Okay, and 3 pi over 4 is outside the range. Okay, so this is wrong because 3 pi over 4 is outside the range. It's outside the range of tangent, arctangent. So that is the argument. That's the argument. Okay. In our lessons on tangent and arctangent, we know that arctangent is a one-to-one function. Okay. So let's review, right? Arctangent. Okay, we used to use that notation of arctan, right? We know that this function is one-to-one. This function is one-to-one, right? This function is one-to-one. Its inverse is just one piece of tangent function. Okay, it's just a one piece of tangent. What is that one piece? That one piece, if we are to specify it, is that A is between negative pi over 2 to pi over 2. So these two functions are inverse to each other. This function is inverse to the other function, not the tangent with that we often mention. So this is what the tangent that's otherwise, otherwise specified. So these two functions are very different. Okay, so note, okay, tangent function, oops, wait, oops, what I'm doing, okay. So tangent, okay, and this function, they're different. What is the difference? What is the difference? Well, this function, this tangent function has many pieces, Okay, so if we graphed it, and this is tangent function, Okay, and we have many such pieces. Okay, we have many such pieces. Okay, I'm going to give you more pieces. Okay, maybe this is a little bit too much. Okay, let's not using so many pieces. Okay, so let me do this. I'm just making some adjustment, right? So this is tangent function. And what is this piece? Right? What is this piece? This piece is just this piece in the middle, right? This is the piece when we otherwise specified, we specified this piece, okay? This piece, so let me draw it. This little piece, okay, forgive me, it's not gonna be, it may not be perfect drawing. This piece, okay, which is boxed between negative pi over 2 to pi over 2, which is a box in between this interval. Okay, just this little interval. So it's not the whole of tangent. So this piece is the inverse to arctangent, okay? So of course we know the inverse, right? We know the inverse of I'm sorry, we know arctangent. I should not call it inverse. And we know arctan. Okay, so I'm gonna make it red. Okay, so this green piece has an inverse, and that inverse is the red. The inverse of red. Okay, so when we're dealing with arctan, right? When we're dealing with arctan, which has two, I'm going to draw the vertical asymptotes, okay, and the horizontal asymptotes. Okay, so just hold on a second. Okay, so I'm going to show you with this picture, which is negative pi over 2. That's the horizontal asymptote. Okay, so I'm going to make it red. Pi over 2. Okay, add another one. And that's going to be negative pi over 2. Negative pi over 2. Okay, so make this a green. Adding another piece. Right there. Okay, so now I'm going to just clean up a little bit. Okay, you can see that green piece. Okay, this piece between the green. Okay, I unfortunately I cannot make this the middle piece green and the rest of them different color. I just cannot do that because the software doesn't do it for me. Okay, so I'm going to use it. I'm going to do it manually. Okay, once you understand this, and this is the same idea for the rest of them, for the sine, cosine, arc sine, you know, all of that stuff, right? We talk about these, right? So the inverse of arc's tangent is just a piece of tangent. So this is the piece of tangent. Okay, on my drawing, it cannot be perfect, but this green piece and this red piece are inverse function to each other. So the red one, when we use the function arctangent, the output should not be outside this interval. Should not be outside this interval. Okay, so the output for arctangent cannot be outside. It's going to be between negative pi over 2 to pi over 2. That's why it is wrong to have 3 pi over 4. And then you say, isn't, okay, of course, the other argument, because this person gave us the reason, right? The person gave us the reason. Let me clean this up. The student gave us the reason because tangent 3 pi over 4 is negative 1. But unfortunately, at 3 pi over 4, 3 pi over 4 is outside. Is outside this green, the piece of tangent between. Yes, it is true that tangent of 3 pi over 4 is negative 1, but the arctangent of negative 1 is going to equals to negative pi over a negative pi over 4. Okay, so the correct answer, this also shows us the power of domain and range. If you have input from the domain and the output must be in the range. If your output is outside the range, and you're definitively wrong. Okay, all right, so this is the second mistake. Okay, I hope you guys understand it. And the same idea hold true for sine, arcsine, and so on and so forth. That's why it's so important that we went through all those details. Okay, the next common mistake is this one. The next common mistake is this piece. Okay, the student would say, hey, sine, arcsine, right? Write it this way. And a lot of people read it as the inverse sine. Okay, that reading itself is confusing because sine does not have inverse. Okay, sine does not have inverse. Arcsine has an inverse, which is a piece of sine. Okay, let me say it again. Sine does not have inverse. Sine does not have inverse. Okay, sine does not have inverse. And this sine has a domain from negative infinity to positive infinity. Okay, this is domain and range in one sentence. Domain range in one sentence for any real number x. So, and we know it's periodic. It's, you know, it bounces between -1 and 1. So sine, every time we talk about sine, we refer to the sine as it is now. Okay, unless otherwise specified. Unless otherwise specified. Okay, so now every time we talk about sine, this is the sine we're talking about. Domain and range. Domain and range. Okay, however, arcsine has, which is the same as this notation. Okay, so both should be read as arcsine. This should be read as arcsine. This should be read as arcsine. We have explained in class why it is called arcsine. Okay, I'm going to explain it here again. Why it is called arcsine? Okay, after I explain this, okay, after I finish this one, I'm going to explain why it's called arcsine. So this mistake is 1 over sine x. Okay, this is another terrible mistake, awful, extremely bad. Especially when you read the sine inverse. Oh my God, that's going to really set you up. And for this reason, I insisted to use arcsine throughout my lectures. So you can see I didn't use this notation very much. But however, we cannot avoid it because most of the textbooks have adopted this notation. But we need to understand that this is arcsine. This is not sine inverse. It should not be read as sine inverse. It should be read as arcsine. Okay. So to explain this, the sine does not have inverse, right? Every time you talk about sine, it is the sine. This has this curve, right? Now, arcsine, however, has an inverse. Okay, of course, has exactly one inverse. Okay, has a unique inverse, right? At the time we talk about it, we say that unique inverse is rarely mentioned until otherwise noticed, right? And the inverse, it is, what is it? It is this function. It is sine x, and x is in between negative pi over 2. That's how we drop the, you know, when we cross out quadrant 2 and quadrant 3. Okay, if you like to make connection to the unit circle. So, and this function, okay, this function and the sine function are different. This function and the sine function are different. Okay, so let me make some more space here. So this function, so when you talk about sine, okay, sine, and this sine with otherwise specified, right? This is otherwise specified, are different. Okay, how different? Okay, so this sine is a piece of, you know, I'm going to show you the piece. Okay, I'm going to show you that little piece. So this piece is between is between these two lines, negative pi over 2 to pi over 2, right? We have talked about this and the graphing of it and all the no-fly zone, etc., right? So I'm going to put this, oh wait, let me do this. and negative pi over 2. Whoops, I'm sorry. I tried to make it faster. I forgot what was in the buffer. So negative pi over 2. This is just a syntax, okay? You don't have to know what I'm doing here. Between these two. Okay. Oh, gosh. Okay, I have to make some adjustment to the. Okay, so this way. Okay, so this sine is just a piece between the two green line, between the two green critical line, vertical line, and sine inverse, which is the bad way of reading it, right? Don't read it like, don't read the sine inverse, read arc sine. So even when you see this, you still read arc sine, okay? I'm trying to train myself to do that, okay? Because I know what I'm talking about, but this can set people up when the people don't know it. Okay, so arc sine, I'm gonna draw and make it red. Okay, and this red piece, okay, and the green piece, and the green piece, right, and the green piece is this piece, is that function, okay, otherwise specified. You see, otherwise specified. So this green piece and the red piece are inverse to each other. So that's why we say arc sine has a unique inverse. It is this piece. It's just a piece of sine. It's just a piece of sine. Okay. And these two functions are different. Sine x, when you talk about sine x versus you talk about sine x between the interval, these two functions are considered completely different. Sine x is considered the entire sine curve, right? From negative infinity to positive infinity. And this piece, right? And this piece is just the green piece between negative pi over 2 to pi over 2. Okay? So now, with that understood, right? With that understood, we know that arc sine has a domain, has a range, right? We know arc sine's domain and range. Do we? Do you know that? Maybe you'd like to write it down at the moment, right? What is the domain for arc sine? What is the range for arc sine, right? So arc sine as a function has input. The input are ratio, and the ratio are between -1 to +1. -1 to +1. And the output are angles. And those angles are going to be between negative pi over 2 to pi over 2. We understand that, right? So now let's go back to talk about why this is a mistake. This is a terrible mistake, especially this one confuses with reciprocal, with reciprocal because 1 over sine x is a cosecant x. Okay, so first of all, okay, this demonstrates the confusion of the student, right? This piece equals to cosecant x, right? Secondly, and if you look at the both sides, this is a terrible mistake. Why is a terrible mistake? With all said and done, we just mentioned that arc sine has a domain and range. It takes ratio. It takes ratio as input. It produces angle, an angle between negative pi over 2 to pi over 2. But what is 1 over sine x, right? If you look at 1 over sine x, the order of operation is that you first take x, right? and x is going to be given to the function sine x. Okay, and then after you get the ratio, you take that ratio and you divide it by sine x. So you first get the sine x, sorry. You first get the sine x, do it this way, and then you do the reciprocal. So you 1 over sine x. So in that regard, the domain x cannot be what? Cannot be k pi, because k pi makes x equals 0, right? Makes sine x equals 0. So sine cannot be k pi. So the input for the for 1 over sine x are angles, and the input for arc sine are ratios, which is only from -1 to +1. You can see from the domain's perspective, they have no connection whatsoever, and much less to say they're the same, right? That they're not the same. So this is a terrible mistake. I think it may be stemmed from the reading of sine inverse. And then the student get confused with inverse with reciprocal. Okay, inverse and reciprocal, very different. We talk about inverse throughout the semester, right? Reciprocal, okay, let me give you examples, okay? And thirdly, we like to talk about the difference. Okay, third, the difference between inverse of a function and reciprocal of a quantity. QU. Okay, now, so let's look at the difference between inverse of a function and reciprocal of a quantity. So let's first talk about the reciprocal of a quantity. You can do reciprocal of any quantity, right? For example, the reciprocal, I'm going to make a table for you. Okay, and we have a number of columns, right? So you have a quantity here. You have a number here, just a quantity. Yeah, a number, whatever. And you have an entity. Okay, and it's reciprocal. Okay, reciprocal. Right? If to say if you have 2, the reciprocal of 2 is 1 over 2. And if you have 5, the reciprocal of 5 is 1 over 5. Okay, and if you have x, the reciprocal of it is 1 over x, right? Provided that x cannot be 0. Okay, x cannot be 0. We have a reciprocal function, don't we? Right? We have a reciprocal function, which is f of x equals 1 over x. And of course, sine x has a reciprocal, right? So these are reciprocals. Okay, and you can create, many different kinds of reciprocals. For example, you say x squared, and its reciprocal is 1 over x squared. They are reciprocal. Okay, so many examples could apply. Inverse function. Inverse function has to be a one-to-one function. In the making of inverse function, right? In the making of inverse function is that one's domain is the other's range. So we swap input with output. We swap input with output. For example, in the making, when we look at, we just talked about sine doesn't have inverse, right? But the arc sine has an inverse. Okay, so let's look at the making of this process. Okay, so arc sine has an inverse in this particular example, which is most relevant to our study, right? So I'm going to make a table again. This table, I'm going to make it that way. Just 3 columns, more rows. Okay, so I'm going to make another table. I'm going to make two such tables. Okay, one is for sine, one is for arc sine, one is for arc sine, and it has inverse, and the other one is its inverse, right? And what's the inverse of arc sine, right? This piece, right? We talk about it. It's a piece of it. It's a piece of it. So now it's the next function. So now we look at this table comparatively, right? And each one has input output. And the input for arc sine are ratio, right? Ratio has to be between -1 to +1, right? Ratio between -1 and +1, right? And its output, the output is going to be between -pi/2 to pi/2, right? So we have this all set up, right? But this function is a piece of sine, right? We just explained it. And the input for this one, even though it's called x, is really just this x and this x, they're totally different, okay? This x is an angle and this x will be considered ratio. So that's why I've been using A, because it doesn't matter which symbol you use because symbols are just placeholders, right? So angle, and it produces ratio. So this piece, we have angle and then we produce ratio. Okay, we produce ratio. So let me make the font just a little smaller so we can hold more, we can show more things in one. Okay, so suppose that I have 25%. So that way you can see the -1, you can see the negative sign here. So now let's look at the relationship, right? So ratio and angle, right? Output is angle, right? So you can see right here, ratio, angle, angle, ratio. So these two functions are inverse to each other, meaning that one's domain is the other's range, one's range is the other's domain. And also you see concrete relationships, right? For example, if I have half, right? Arc sine of half, right? Arc sine of half, 2/1, that's equals to pi/6, right? We are familiar with that. And so input output, the input is half, the output is pi/6, right? And the domain range is spelled out. And on this piece, if we talk about pi/6 as input, sine of pi/6, sine pi/6 equals to 1/2. So this is the one-to-one correspondence between a function and its inverse. Okay, so pi/6, the input, and the output is 1/2. You see, the inverse function in this relationship is that input-output swapped. Input-output swapped. So that's why the inverse functions is entirely different in meaning from reciprocals. Okay, so let's do a couple more so that hopefully this will help you to refresh, right? So this is √2/2, and then you have arc sine, right? I'm going to read arc sine. Okay, I'm going to explain to you why arc sine. I explained that in class. So this is a pi/4, right? That's the output. So when input is √2/2, the output is pi/4 for arc sine, and it's unique. Okay, 1-to-1. Okay, and for the other function, for its inverse, for arc sine's inverse, and sine of pi/4 is equals to, and of course, you know that's √2/2, right? That's √2/2. Okay, and now we have that one-to-one correspondence, one-to-one correspondence. Okay, You can keep going. Now, okay, you can fill up. Okay, I can give you some numbers for you to fill up, right? So the next number I can give you would be √3/2, right? You fill this up. And this one, of course, is going to be pi/3, right? And I can have 1, right? And this is pi/2. So you're going to fill up these, and you're going to have it. Hopefully this will give you a different perspective, right? So now I'm going to extend this table, insert 4 rows, insert 4 rows here. Okay. And of course, I can have a bunch of these numbers that are negative, right? So negative, 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 negative. So you will know what to do, right? And these numbers, and these are pretty familiar numbers. You can just work with it, through the process. Think about what I just said, right? And in general, if you have if you have any x, right? And that x is between -1 to +1, right? And arcsine x is going to say equals to theta, right? So this piece, this will be general notation, so right? So x theta, right? And the other piece will be the theta, and theta could be any one of these or more, right? Everything between -pi/2 to pi/2. And then at that point, sine theta would equals to x, right? So if you have a input output expression, so this is you can see that the inverse relationship is such. Okay, be sure to fill up these numbers. Okay, you can pause to fill up these numbers. It's very important for you to understand this. Very important for you to understand this. Okay. Since you're here, maybe we just do it. Okay, so it's pi/3. And so we're going to do all of these. So this is going to be 1. This is pi/2, right? And you're going to make up those numbers. And I'm trying to be quick because I don't want to make this super long to make you feel burdened. But if this helps, right? If you just do it yourself, and it really enhance the understanding. Okay, really enhance the understanding. Okay, and these, what I'm going to do is, and I'm just kind of copy and paste and just changing the sign. Okay, so this is going to make it. It's my lazy way to do it. Okay, it's my lazy way to do it. So this is a negative. And this is negative. And this is negative, 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 negative. And of course, here is going to be -1, and it's -pi/2, negative pi/2. On the other side, you see similar relationship. This is a one-on-one correspondence. Okay, this is a one-on-one correspondence. And so let's do it on the other side, right? Hopefully this will be a helpful review. If you're really bored, just go ahead to just fast forward. Okay, fast forward. So let me do it for you, and I can do it for you for the cosine. Oops, that's 2. That's 3. Right? And sine pi/2. So what I mainly want you to see that these one-on-one correspondence. Okay, how they are truly one-on-one. Okay, so pi/3. root 3 over 2. Just be patient with yourself when you're doing this, okay? If you have some confusion at this point, I think it should be clarified by this time, okay? And the next one, I'm just going to fast forward myself, and you can say I'm kind of lazy, okay, just to reduce my typing. You might be faster than I, because if you write it on paper, this can be much faster. Okay, one-on-one correspondence. And this is the last one is a representative. Okay, it's summarize all of these cases. The last row, which we use to, we use it to work with the expressions and stuff, is just a summary. It's a summary. So the inverse of arcsine is sine specified, otherwise specified. So that's what it is. So now why arcsine? Okay, so I'm going to explain this to you. Why arcsine? Why arcsine is preferred? Okay, and this notation is just a shorthand notation for arcsine. I don't agree with it because it confuses a lot of our students. So for this reason, we're going to explain to you. We're going to explain to you. Okay, so I'm going to take this picture and put this picture over here. I'm going to grab my unit circle. Okay, I have a unit circle here. So I'm going to just recall what we did when we did the graphing. Okay. When we did the graphing, remember the arc length? Remember the arc length story? Right? Remember the story about arc length, how we graph the curve. How we graph the curve, right? For, take an example, sine of pi over 6 equals to 1/2. Okay, now arcsine of 1/2 equals to pi over 6. Okay, now, which is the first row? We have it on the table, right? That's the first row, we have it on the table. Now, why arc length? Once again, when we were graphing for pi over 6.5, this point, right? That point, we graph that, we say pi over 6. So I'm going to graph this point, pi over 6.5, right? Pi over 6.5. I hope this, because I spent a lot of time graphing those points. And I call them arc lengths, right? I use orange color for the arc lengths. Oh, wow, I need to, I probably missed something. Okay. Arc length, oh, my bad. It's 0, 0, and this should be 0. Okay, that's the arc length. You see this arc length, this is orange color, okay, or gold color. This is the arc length, okay, when I'm graphing sine, right? And the ratio half, right? The ratio half, which is on the black curve. There's a point on the black curve. Okay, now, the half, right? So pi over 6 half pi over 6 0, right? And there's a blue. Remember, we use a color blue. Okay, I'm gonna make it thick. Okay, that blue right there. You see that blue, there's a dot, there's a black dot on the sine curve. So I'm gonna put that black dot on the sine curve. So this point represent input, output, input pi over 6. Oh, gee, I meant to make a dot. Okay, so there should be a black dot. Black dot, you see that black dot? Gosh, it looks like on the red. It's not on the red, okay? It's on the, you know, this is actually ugly. Could you allow me to redo this, okay? Because I need to leave, because these two curves are too close. So I'm gonna do a different one, okay? Pi over 3, so this is going to be root 3 over 2. Okay, so now this is root 3 over 2. Okay. All right, so this is a root 3. Okay, some of you, if you understand this, you can just totally, you know, move forward. Okay, so this is a root, this is a pi over 3. I just want to give you an example to explain this without confusing you. Okay, so I need a different point. Otherwise, they're too close. Okay, so this is root 3. Do I have another point? Root 3. I think my mouse might be tired. Okay, so now, so this is better. Okay, this is way better. You can see this gold color is the arc length. What arc length, right? This is arc length. The arc length, oh, sorry. I'm going to use the gold color to match this color, right? Remember when we were graphing this, right? When we were graphing this, we talk about, we take the arc length, measure from the standard position. This arc length stretch straight is this piece of arc length, which is pi over 3. I choose pi over 3. And the blue number is the blue here, right? So input is angle, output is a ratio. And now arc sine, take this ratio, produces pi over 3, and pi over 3 is this arc length. That's why it is called arc sine. That's why you should read it as arc sine. The same reason is true for arc cosine, arc tangent, and so on and so forth. So next, I'm going to draw this arc length on the red curve. Okay, I'm going to draw the arc length on the red curve. Okay, so just give me a little time. So on the red curve, what point would that be? Right, with that point, would that be? It's going to be the blue number. Okay, so it's root 3 over 2. Root 3 over 2. 0. And 0, 0. The blue. Okay, the blue. That's the blue, right? The blue. It's a little shorter, but this blue is root 3 over 2. Okay. Thicker, thick. Okay, see that this blue and this blue, vertical blue and the horizontal blue, they're the same length. Okay, now I'm gonna draw the arc length. The arc length 3 over 2. You don't have to worry about the grammar. Root 3 over 2. And then this is going to be pi over 3. And this is going to be orange. Okay, so for sine function, the piece for sine function, which is the inverse of the red, which is between the green, the orange color, which is a measure from this orange, is the horizontal orange, correspond to the blue. The inverse function, okay, so the vertical becomes horizontal, okay, because that's the input for arc sine. The output is the orange. The orange is pi over 3, which is this pi over 3 right here, is the arc length. And of course, it's also the angle measured from standard position all the way to the terminal here, but it's also arc length. That's why it's called arc length. That's why it's called arc length. Okay, the same is true for arc, cosine, etc., etc. Okay, so don't read it as sine inverse. It confuses you. It confuses you. Okay, it could confuse a lot of people. Okay, so with that understanding, I hope that we can move forward, right? So this is a terrible mistake. We see this. We saw this in calculus class. We saw this in calculus class. Okay. Let's see. How about cosine? How about cosine? I think it might be necessary for me to do this table for you for cosine. Because the following reason. Okay, because cosine's inverse, okay, I'm sorry, arc cosine, what I'm saying, okay, arc cosine, okay, arc cosine, their domain is the same, but the range are different. So, so this cosine is between 0 to pi. I'm changing it over it so you can see the difference. Okay, this is not because of laziness. Okay, this is not because of laziness. Okay, and the range for arc sine. Okay, the range for arc sine is between 0 to pi. Okay, so domain is the same, and the range is from 0. So this is going to be arc cosine. So I'm changing it one by one between 0 to pi, inclusive. Inclusive means that the points at endpoints are included. Okay, so this cosine, its inverse is between 0 to pi. Okay, between 0 to pi. So arc cosine, so all of these has to be redone. All of these has to be redone, of course, okay? So let's do the first one. Let's do the first one, okay? Do the first one, and we know that, arc cosine, the no-fly zone is the, yeah, let me also put the no-fly zone there, okay? For sine, no-fly zone, you see, we always can add some more, right? To make it nicer, to make it better. Okay. Because I mentioned this, okay, so therefore I'm going to bring you the no-fly zone as well, because I think those pictures will make a lot of sense for you. And of course, the unit circle, right? And of course, the unit circle. So all of these combined, you have to see them together. You have to see them together. Okay. So what I'm going to do is I'm going to just make this adjustment once, and then hopefully I don't have to do it all the time. Okay, so be patient with me. I just really want to communicate this with you, right? For arc sine, then we have a no-fly zone. right? We have no-fly zone. So let me draw that no-fly zone. Right there. Okay, so no-fly zone. No-fly zone. Okay, and no-fly zone, and you also have that unit circle along your side for your, you know, for whatever. Okay, so all of these, right? So you have, when you look at these, you look at them all together. So now we do cosine. We do cosine. Okay, I'm writing them over because I want you to see the difference. Now, all of these is going to be arc cosine. Okay, so take this opportunity to review this. Okay, cosine, arc cosine, right? Arc cosine, of course, this is pi over 3. This is pi over 3. Arc cosine, right? You may have your unit circle next to you and the no-fly zone. Okay, I'm going to bring the no-fly zone over with us. Okay, I just have to modify this no-fly zone. I'm going to bring both together. Okay, we're working with the cosine, right? All right, let me make it just a little smaller. Okay, the no-fly zone need to be adjusted, right? And this should be 3, -3. That's a no-fly zone. I hope I don't get you really bored. Okay. All right, okay. I think this will do. Now, arc cosine √2/2 is pi over 4. That's so good. Arc cosine √3/2, that's pi over 6, right? You can always look at the unit circle there. And this is pi over 6. Arc cosine 1, what does arc cosine 1 equals to, guys? It's not equals to pi over 2, right? What does it equal to? It equals to 0, right? So 1, 0. Okay, and then what? Arc cosine -½ where would it be? Yes, it's going to be 2 pi over 3. 2 pi over 3. Okay, 2 pi over 3. You see, when we mention the output, right, for arc cosine, the output is between 0 to pi, right? We cross out quadrant number 3 and quadrant number 4. So your output will never be negative. Your output will never be negative, no matter what input you pick from -1 to +1. Okay, so now we change it over. So now arc cosine -√2/2 is not going to be -pi over 4. It's 3 pi over 4. It's 3 pi over 4. Okay, you can look for just the red number. Okay, from the red number. Okay, from the red number to the angle, measure from standard position counterclockwise. That's what you do. So arc cosine -√3/2 is going to be equals to 5 pi over 6. 5 pi over 6. Am I right? Yes. Right. So this is not going to be -pi over 6. This is 5 pi over 6, guys. Now arc cosine -1, what does it equal to? It equals to pi. So this is pi. Okay, now arc cosine. Okay. Whoops. So arc cosine x equals theta, and of course x is a ratio, theta is an angle. okay? Or we can write arc cosine this way. Oops, sorry. Arc cosine this way, but you still read it as arc cosine, okay? Still read it as arc cosine. Now, let's see what's on the other side. What's on the other side? Just completely, you just reverse a swap input with output. You just swap input with output. So what do we get on the other side? And this is going to be cosine pi over 6 equals what? Equals to root 3 over 2. Right? So that's going to be root 3 over 2. And the this is a cosine, sorry, cosine, and this is a cosine, and that's going to be the same, right? That's going to be the same. Just double check cosine. This one is blue number, one is red number, right? One is, and now you can bring the unit circle right next to you to do that. Okay, of course, this is going to be half. Are we right? Are we right? Yeah. Okay. And what is the cosine pi over 2? 0, right? So that's a 0. Okay. If you like, bring that unit circle right next to you. Okay. Just blue number, red number. If a cosine is a red number, right? Cosine pi over 2 equals 0. Now cosine 2 pi over 3. 2 pi over 3 is negative half. Cosine 3 pi over 2, 3 pi over 4 is going to be that. Okay, cosine. And cosine of 5 pi over 3, I mean 5 pi over 6, sorry, 5 pi over 6 is negative root 2 over, and finally cosine pi equals negative 1, right? So this is a pi, and this is a 5 pi over, so I'm changing all these numbers, and I'm sure I need to make more changes, okay? And I hope you guys are with me at this moment, so I don't make any stupid mistakes. And I think this is half, negative half. Wait, am I right? Let me double check, okay? Negative half, negative root 2 over 2, that's correct. Negative root 3 over 2. Negative root 3 over 2, that's 5 pi over 6. 5 pi over 6. So cosine 5 pi over 6 is a red number, root 3 over 2. Cosine pi equals negative 1. That's correct. I think we're good, aren't we? And here, of course, we have to write it down as a cosine. But this cosine, okay, this theta is where? This theta is between 0 to pi, which is the range of cosine. Okay. So now, do we have a picture similar to that of sine? Do we have a picture similar to that of sine? Of course, of course. Okay. So I'm going to bring that picture to you. And of course, I need a unit circle again. I need that unit circle, right? So this is going to be, I'm going to redo the whole thing. Okay, so this time it's going to be cosine. Okay, it's going to be cosine. And of course, we're going to have arc cosine, right? And that's going to be between 0. So that blue area, that green area is which, and this is 0. Okay. Be patient with me, please. Okay. So I'm going to draw the picture properly. So this is going to be arc cosine. Okay. For these ones, we're gonna change later. So maybe this is half. Okay, so now we're gonna stop here. Okay. There needs some changes. The blue and orange. The blue will change to red. Okay, the blue will change to red. Hold on. On this picture, I need to make some adjustment because this time you see the cosine piece is between 0 to pi. So this piece and the arc cosine. Okay, arc cosine's range is between 0 to pi. So I have to make some adjustment. Okay, so that's arc cosine. You see that red piece is arc cosine. So when I'm doing I'm going to do, you see this piece between the green, that piece between the green. Okay, so this piece, oh, this is so too thick. Okay, so this piece cosine is the inverse to the red piece arc cosine. Okay, so that's the cosine otherwise specified. Okay, so now with that said and done, so I'm going to show you that arc length thing. Okay, so the example we're going to use, let's see, I'm going to use pi over 6. Okay, I'm going to use pi over 6 this time to see if that helps. Okay, because we have to see the picture. We have to look at the picture, right? The picture, so I'm going to use pi over 6. That's the orange. Okay, so pi over 6, and this is root 3. And it's going to be red because what this demonstrates is I'm going to demonstrate the orange color. So let me just remove a bunch of things. Okay, I'm going to remove a bunch of things. Remove that, remove that, remove that, remove that, remove that. Just make it cleaner. Okay, now this is a cleaner. Okay, this is a cleaner. Okay, so now let me just make that narrative again. Okay. The red is our cosine. Okay, the domain is between -1 to +1, right? If you look at that piece, right, from the domain from -1 to +1, the range is from 0 to pi, right? So the picture shows. And this red has an inverse. Okay, its inverse is between the green vertical line, the cosine. So this piece. Okay, I don't like that color. No, I don't like the color at all. Green. Okay, so this piece of cosine is the inverse to the red piece arc cosine. So that is the cosine between 0 to pi. That's 0 to pi is the otherwise specified. Okay, so now, so what I'm going to draw is that I'm going to try to draw this to show you the idea of arc cosine, right? See, we have a cosine pi over 6 equals to 1/2. Is it? No, pi over 3, sorry, pi over 3. Well, we just have to look at the unit circle, right? Are we confused? Cosine pi over 6 is root 3 over 2. Okay, so pi over 6, the arc length is the arc length. So I'm going to draw you the arc length. I'm going to draw the arc length for you. So you can see the idea is the same. Arc length. Okay, and then root 3 over 2. Root 3 over 2. Right, so, well, no, I don't need that anymore. Pi over this over here. I will wait a little, okay? So that arc length, I'm going to use the orange color. That's the arc length right here. You see that arc length right there? And next, I'm going to draw the red, okay? The red number, which is root 3 over 2, okay? So that's going to be over here. Right there. And the root 3 over 2. And this is the red piece, red. Okay, you see this is the orange and that's the red number. Remember when we graphed the cosine, that's what we did, right? We did it from -2 to pi to pi. Now I'm explaining to you the arc length. Okay, so now we know that arc cosine of root 3 over 2, which is a ratio, will produce us the arc length of pi over 6. Why it should be called arc cosine. Okay, so this is the input and that's the output on the red, Okay, so this dot, pi over 6 root 2 over root 3 over 2, that's on the cosine curve. Okay, pi over 6. And root 3 over 2. And that red dot is on the cosine curve. Now I'm going to draw you the other one, which is on the red curve, which is the arc cosine. Arc cosine. Okay. Well, that black dot looked like it is on the other one, right? So now it's red is going to be lying down. Okay, the red is going to be root 3 over 2. Okay, so 0, 0, and here's 0. Okay, so this is the red lying down. Okay, so this is red is lying down, and it will give us the arc length. The arc length is going to be pi over 6. We can make adjustment because if you don't, I hope to give you a clear show. Okay, so this is root 3 over 2. Zero. Root 3 over 2. Then pi over 6. Pi over 6. It should give me that arc length. Right here, right? So you see that dot, that little dot? I'm going to put that dot right there. That's root 3 over 2, comma, pi over 6. Red dot. You see the black dot is on the cosine curve and the red dot is on the arc cosine curve, and the orange is the arc length. That's why it is called arc cosine. That's why it is called arc cosine. Okay, so I'm just trying to convince you that it should be called arc cosine, not cosine inverse, because it's going to confuse so many of us. Okay, tangent, I'm not going to do tangent at this time because this has been too long. Okay, we still have other mistakes to cover. Okay, so let's see. Mistake number 4. Mistake number 4 to cover. Number 4 mistake. Number 4 mistake is this one. I think this might be the last one. Okay. Arctan equals to, so let me write it down larger, 200%. Okay. Arc sine of x 75%. And arc cosine. Oh, this is a miserable mistake. Miserable. If some, I know you guys will not make this mistake, but just in case, okay, just in case. This is a terrible, horrible, extremely bad mistake. Well, what is domain for arctangent? It's from negative infinity to positive infinity. And what's the domain for arc sine? From negative 1 to positive 1. You know, the domain for arc cosine is negative 1 to positive 1. And if sure, we can require cosine, arc cosine not equal to 0, but still, this is a terrible mistake. This is a terrible mistake, okay? To show this mistake is terribly wrong, all we have to do is just using some examples, okay? So, no, it is terribly wrong. Okay, terribly wrong. But how do you convince people who believe it, right? Well, we just have to use, let's use some numbers, okay? So suppose I'm choosing x equals to half. X equals to half. Whatever, I'm gonna choose, I'm trying to choose some numbers that make it easier to calculate. Okay. Let's choose 1. How about 1, right? 1 is easy. And the left-hand side equals what? Okay, if it doesn't work, we try another one because we know this is a mistake. Okay, so the arctangent of 1 equals to pi over 4, right? Equals to pi over 4. How about the right-hand side? The right-hand side, and this is 1. I actually don't know what that equals to. Okay, so let's use our calculator. Okay. Oh, wait. Of course we know. I think I'm tired. I don't know if you're tired too. You know what? Actually, we cannot use arc cosine 1 because arc cosine 1 equals 0, right? 0 cannot be the denominator, right? So we have to choose a different number. Okay, let's just choose a different number. How about -1? Right? How about -1? Right? -1 is okay. So this is a -1. So let's go to see if it works. Arctangent -1 is negative pi over 4. So now what is the sine? What is arc sine -1? It's pi over 2, right? It's negative pi over 2, sorry. It's negative pi over 2, right? Yes. How about arc cosine -1? That's a pi. So what does this equal to? Negative pi over 2 divided by pi equals to -1/2. Obviously, negative pi over 4 is not equals to -1/2. Okay. This is that's why it's a terrible mistake. So please don't make this mistake. Okay, horrible mistake. Okay. All right, so I think these are the 4 major mistakes, and we use these, and I'm going to point out another mistake, is that if sine of A equals to sine of B, can we say then A is equals to B? Can we do that? Of course, I told you it's a mistake. This is a mistake. Why? This only apply if the set function are 1-to-1. We know sine function is not 1-to-1. Okay, only 1-to-1 mistake, only 1-to-1 function can have such property. In other words, for 1-to-1 function, right? Only for 1-to-1 function. Okay, only for 1-to-1 function. Okay, when the output is the same. So suppose we have a 1-to-1 function g, for example. When g of A, when the output is the same, and then the inputs are same. Only for 1-to-1. So here, sine is not 1-to-1. Sine function is not 1-to-1. Sine function is not 1-to-1. Then you say which sine function? Of course, it's a sine function we know, right? Because there's no otherwise specified. It's a sign that have domain on all real numbers between -infinity to +infinity. Okay, sine is not a 1-to-1. Thus, it is false. It is a false. And it's a false statement. It's a false if statement. Okay, and we can easily give counterexample. Right? And that counterexample I can easily give you, so easy. Sine 0 equals to sine pi, isn't it? Because sine 0 equals 0. Sine pi is equal to 0. Can we say 0 equals to pi? 0 does not equals to pi. Right? Right? So we say, but 0 is not equals to pi. Okay, so this is the mistake. Oh, I actually think of one more mistake. I saw this mistake often. Excuse me. I need some water. And this is the mistake I saw. Okay. Say solve for, in the question of solve for say A or X, right? A. Okay. And here we say sine, and the equation given is sine of A equals to 1/2. Okay, so this is the question. Okay, this is the question. A student's work, okay? And this student will take this equation, right? And the student will say, hey, I'm going to take arc sine on both sides. I'm going to take arc sine on both sides. And the students say, okay, let's do it. right? So arc sine. And then they will cancel the sign and they will read it as sine inverse, which is a terrible mistake, right? And the students say, hey, the answer is pi over 6. In this case, it's a terrible, horrible mistake because what is wrong? What is wrong? What is wrong? Because these two functions are not inverse to each other. Okay? The inverse of arc sine is sine. Okay? The inverse of arc sine is sine where x is in that specified, that otherwise specified interval, negative pi over 2 to pi over 2. And here we don't have such a specification for this sign. When this sign is mentioned, right, in this, okay, so, but not sine of A, not a sine of X without any specification. Okay, we just talk about this function and that function, they're totally different. They're totally different. Okay, and so that's the first aspect. Okay, so note, so first of all, so I put it as A, B. In the statement here, okay, in the statement as such, okay, in this statement, okay, sine is referred to, okay, sine is the function with domain all real numbers, all real numbers. So the search for solution, okay, so it's the search for solutions is in the entire domain of all real numbers. Okay. All right. So this is the mistake. This is the source of mistake, because this is only true if the two functions are inverse to each other, but they're not inverse to each other. Okay. And how, of course, you guys know the answer. You know how to solve this just in case, right? So to solve this equation, right? And we have to identify the terminal. The terminal has one terminal in the first quadrant, another terminal in the other terminal from, you know, this is special angle. We've done this before, right? So just for simplicity, right? Just for simplicity, because this lecture has been too long. For sine, to solve this equation correctly, okay? To solve this equation correctly, and this is what you do. Okay, so to solve it correctly, right, you identify the two terminals, and one terminal is here, right? Another terminal is right there because there are two blue half, right? So as a result, our solution would be A equals to, oh, forgive me, those things don't cooperate. Okay. So the solution, we have two sets of solution. We have an infinite number of solutions. Okay, we have infinite number of solutions. Okay. And these solutions, of course, you already know, most of you already know. I hope that I don't bore you too long, right? Plus 2k pi. And the other one is 5 pi over 6, right? Plus 2k pi. This is related to how we measure the angles. And k are any integers. K are in any integers, okay? So don't do that. Don't do that. You can't do that. Even if you do that, you should not, you're not getting pi. The left-hand side is not going to be A, right? So it's not going to get you there. It's not getting there. So that's a terrible mistake. I think I have covered all the mistakes I can think of at the moment. Okay, if I see more, I should be able to tell, but I haven't seen more. But thank you for watching. This lesson has been pretty long. And I assure you, it is going to be helpful, not only for your trig class for the final exam, it's going to be helping you for the future classes. Okay, so thank you for watching. Goodbye.